Hi, this is A-Level Maths Tutor UK, and in today's video, we're going to look at proving two trigonometric identities. So we're going to prove the identity that sin theta over cos theta is the same as tan theta, where theta is a real angle, and also this second identity, sine squared plus cos squared equals 1. So we're going to prove these two identities today, and these are two identities that you need to learn for your A-Level exams. So let's start with the first one then, to proving that sine theta divided by cos theta is tan theta. So we start by looking at, or recalling our definitions of sin, cos, and tan with this one. So remember that sin theta is the same as the opposite side, the ratio of the opposite side to the angle theta, divided by the hypotenuse. And also the cosine of an angle is the adjacent side to the angle divided by the hypotenuse. So that means that sin theta divided by cos theta is the same as the opposite side over the hypotenuse, so sin, and then divided by cos, which is the adjacent, divided by the hypotenuse. So when we divide two fractions together, we keep, change, flip. That's kind of our rule to divide fractions. So we're going to keep the first fraction the same, the opposite over the hypotenuse, keep that one the same. Change the division to times sign, the opposite of division, and flip our last fraction over. So we get hypotenuse. Let's just write this again, hypotenuse divided by adjacent. Now, what we can see here is that we've got hypotenuse on the top here divided by hypotenuse. So that just cancels out there. And so we're left with opposite over adjacent. And we know that the opposite side, the ratio of the opposite side to an angle over the adjacent side is exactly the same as tan theta. And so therefore that means that sin theta or sine theta divided by cosine theta is the same as tan theta. So that's how you would prove the identity. Now let's look at our second identity. So this one, sine squared plus cos squared. So remember that sine is the same as the opposite side to the angle divided by the hypotenuse, but we want to square it this time. So we're squaring the sines. We're going to square all of this. And then we're going to add that to the cosine squared, which is the adjacent side divided by the hypotenuse side, all squared. So that's that. So this is essentially opposite squared over hypotenuse squared plus adjacent squared over hypotenuse squared. Now we've got a common denominator with these two fractions, so we can just write it like this instead. So we get hypotenuse squared on the bottom with opposite squared plus adjacent squared there. Now let's think about this right angle triangle up here. When you do adjacent squared plus opposite squared, you get hypotenuse squared. Why is that? That's because of Pythagoras. So the two smaller sides, the sum of the square of the two smaller sides of a right angle triangle gives you the square of the hypotenuse. So actually using Pythagoras, we'll just make a note that this is Pythagoras. So using Pythagoras, this tells us that the numerator is just going to be the hypotenuse squared. So a squared plus b squared equals c squared. So this is hypotenuse squared over hypotenuse squared, and a number divided by itself is the number 1. So therefore sine squared plus cos squared is the number 1 for all angles theta. So theta as a real number. So yeah, that's how we would prove the first identity, sin theta divided by cos theta is tan theta, and also sin squared plus cos squared is 1. That's how you prove these two identities.